Yes, students, thank you very much uh, for inviting you to my wonderful teaching today. Today we are going to talk about this Modi method. Okay, Modi method of solving transportation problem. That is what we are going today. So there are a lot of steps are involving. Nearly 11 steps are involving this Modi method. Okay, first step is that we have to find the initial basic solution by any one of the method. I mean, any one of the previous method. Okay, that's what you have to understand. Any one of the previous method. That's very important. Any one of the previous method. Previous method. I mean, um, P or E previous V A O U. Yes, any one of the previous method, we have to uh, we have to do that. We know that what are the previous methods. Am I correct? Least cost method, and then northwest corner rule method, and then Vogel's approximation method. So by any one of the method, we must find the initial basic solution. That is the first step. In the second step, we have to find the fixed cost for basic cells. Okay, basic cells, we know that the cells in which the assignment was made, okay, the assignment was made, are called basic cells. So we have to find the fixed cost for basic cells using the formula Cij equals ui plus vj. Cij equals ui plus vj. By using this formula, we have to find fixed cost for all basic cells. Okay, and this is what the second step. Then comes third steps. In the third steps, by setting u1 is equal to 0, by setting u1 is equal to 0, it is possible to find all ui's and vj's. UIs and VJs. That is, the previously we have seen this formula Cij equals UI plus Vj. Those UIs and Vjs can be found out by setting y1 equals 0. Okay, so that's what we can do by step number 3. In step number 4, of course, we can calculate net values. Net values we have calculate for non-basic cells. For non-basic cells, we have to find the net values by using the formula Ij equals Ui plus Vj minus Cij. So this we have to calculate, that is net values we have to calculate for non-basic cells. So non-basic cells are cells in which we are not assigning products to transport from the production center to uh, the destinations. Those are cells are called non-basic cells. So for non-basic cells, we have to find the net values by using this particular formula. Ij equals ui plus vj minus eij. Now comes the fifth step. In the fifth step, okay, if all the net values are 0 are negative, okay, here all the values are 0 are negative, 0 are negative, 0 negative, are negative, and negative, 0 are negative, then optimum is reached. Okay, optimum is reached if all the net values are 0 or negative. Okay, so if not, then we have to go to the next step. So fifth step is very important step because we have to look into all the net values calculated by the step number 4, calculated by step number 4, and see all of them are 0 or negative. Okay, if all of them are 0 or negative, then we have reached our optimum, that is minimum among minimum. If not, that means if any positive values are occurring there, then we have to go to the step number 6. We have to go to the next step number 6 we have to go for. Okay, so step number 6 is that we have to form a loop from maximum positive net values. From maximum positive net values we have to make a loop. Okay, so forming a loop means what? We can go straight to the row wise or column wise. Column wise or row wise you can go, but we should not cross the cells like this. Okay, that is the first step with which we have to draw the loop. Second one, all the corner points must be a basic cells. Suppose we are drawing a loop like this, then all the corner points, here what are the corner points, you can say, suppose these are the corner points, this one is corner points, all the corner points must be assigned values, so assigned cells or basic cells we say this. Okay, these corner points must be the basic cells. That's what one condition. Second condition, it has to go through uh, row wise or column wise. Okay, that's the next point. And that is the second point. And it should not crash. Then where it starts, it has to end there. Where it starts, suppose the loop starts here at the point A, then it has to end. Okay, it has to end there. It can go clockwise direction like this, or anti-clockwise direction like this. Okay, anyway we can go. So these are some of the conditions that we have to make a loop. Okay, we have to make a loop. On the basis of that we can make a loop. So the problems comes there. We can make a loop there like that. Okay, now we have to assign the value theta and minus theta. uh, that we are forming a loop like just now I was explaining to you. And after we have to theta and minus theta, we have to assign theta and minus theta for theta assigned places. Okay, we have to assign theta and minus theta for corner points of the loop. We had the loop like this. Okay, so at this particular corner points, starting from the here theta minus theta, theta minus theta, theta minus theta, then theta, like that we have to assign theta values for the corner points. Okay, that's the next step. Now the eighth step, that we have to assign the value for theta. So theta we have to assign the values. How to assign the values? Minus theta assigned cells. We have to see the minus theta assigned cells. What is the minimum of the assigned values? Minimum of the assigned values. Okay, that's very important. Minus theta assigned cells we have to take. Then among them, what is the assigned values? The minimum of the assigned values is SIGN ZNMANT. Assigned ED. Assigned value we have to give to theta. Okay, that is step number 8. Then comes step number 9. We can rearrange the entire basic cells by using this particular theta values. By using this theta value, it is possible to assign a new value for that. Okay, that is step number 9. Now next comes step number 10. After assignment of or rearrangement of the assigned values, we have to calculate the total transportation cost. Okay, we have to find the total transportation cost, and definitely we will see that the transportation cost would be equal to in the previous case or less than that. Okay, So it is previous than or less than that. Okay. If it is equal, then that's all the solution. Suppose it is less than that, then again we have to find the step number two onwards. Step number two onwards, we have to find step number two onwards. We have to do the problems again and again, and then finally we have to check the net values. If all the net values are zero are negative, then we have reached our solution. If any positive number comes, again we have to draw the loop, assign the value theta minus theta, and then for theta we have to choose the minimum of minus theta assigned cells. In that, what is the assigned value, that value you have to take, which is the minimum that we have to assign, and we will get a new value, and we will get a rearrangement of the basic cells. And again we are finding out the transportation cost. It would be minimum. Okay. And then we have to calculate the fixed cost and net values. If all the net values are zero or negative, then we have to stop. So our optimal stage reaches when the all the net values are zero or negative. Okay. And that will give us the solution for the given problem, and that would be definitely an optimum. And if you multiply the corresponding transportation values, I mean the solution set, by the corresponding transportation cost, if we add all of them, we will get very least transportation cost. And this particular method we call it as MODI MODI method. Okay, MODI method, modified method of finding solution for the given transportation problem. So with that, I come to the end of this problem. The next class I would be taking another, but before that, here you must note that the total value would be equal to summation of Cij, the transportation cost from ith production center to the jth destination, multiplied by the number of items we are transporting from ith to jth destination. Okay. This is a way we can calculate the total transportation cost. So with that particular step, I do want to come to the end of this session, and the next session we will be taking another problem and we will be discussing that. So thank you very much.